So this will be an embolization device that's using intracranial aneurysms. So an aneurysm is a bulging of the artery abnormally, and that's because of the structural weakness of the actual vessels. And that's caused through different factors. But the risk is that it could actually rupture. So usually it swells and it eventually ruptures, and that causes internal bleeding. So when a patient has this, they usually have a couple minutes to treat the case. Most of the times it results in death. But there's different types of aneurysms, and the most common one being saccular. So on the right, there's a picture of different types. And they usually happen at bifurcations or branches of different arteries. So saccular is the most common type, and they're recognized by the berry shape. They can vary in size, being from a couple millimeters to a couple of centimeters. And the location of where these aneurysms occur is also important. So this is an intracranial aneurysms, so it happens within the brain and the arteries leading up to the brain. There could also be other aneurysms in the body, such as peripheral aneurysms in the hepatic ducts. So the major arteries that lead up to the brain is the internal carotid artery, and then that bifurcates into the medial carotid artery and the inferior superior carotid artery. And within this circle in the brain called the circle of Willis is when a lot of aneurysms occur. So here's a chart on the right that can give you a layout of those arteries in the brain and where these can occur. So the treatment, one of the treatments includes putting an embolization device. So it's kind of like a stent. And what it does is redirects the blood flow from the actual aneurysm into the artery. So hopefully it would get smaller or mitigate that impact of blood flow into the aneurysm, so the wall does not elapse or stretch as much. So these are some quick facts about this particular design. They're on the website for Medtronic. And so on number one, that's the actual embolization device. Number two would be a benchtop aneurysm. So they probably made this model on a benchtop. And these are some of the specs found online for the current model that will be designed. So from there, I'm going to jump onto SolidWorks. So here we're on SolidWorks, and this is how the part looks like. So first thing you're going to do, just to give you a layout of SolidWorks, here on the left, we have a family tree. And so this family tree, whenever you make a feature, is going to list that feature. So the first thing we started with here was the axis. So if we go all the way to the beginning, you can see the history of the entire part as it was made from top to bottom. So first thing we're going to do is we're going to make a new part. So here we are with a new part. So we're going to go to features. And if you want to, you can follow along as well. But since we're pressed for time, I'll be finishing this as soon as possible, and we'll take questions towards the end. So if you notice the embolism, in this case, embolization device, the specs for it were a 5mm diameter and a 10mm length. So we're going to go ahead and model that. We check that our units are mggs, so millimeter gram in second. It's a 5mm diameter. So that is good. But the first thing we want to do is add an axis, and this will come useful later. So we can do here, we saw this family tree before. We're going to go ahead and roll this back. So we hide our feature. It's no longer on the timeline. And what we're going to do now is we're going to go add an axis. So let's go to our search bar, and we're going to type in axis. So we can add that axis. In this case, we want to make an axis using two planes. So there's two ways you can select these planes. You can select them on the graphic design window, or you can select them on the left here in the tabs. So we'll go ahead and make an axis from the top and right plane. There's your axis. If you zoom out, see it. And now we have our axis. We bring back our sketch and look at our sketch. There's our circle and there's our axis. So what's next? Next, we want to do is we want to simulate the helical spiral of the embolization device. So we look for a helical spiral, and we create our spiral based on height and pitch, because we know the height is 10 millimeters, and the pitch can be controlled to whatever you want. Reverse direction, clockwise or counterclockwise, and you're good to go. So now you see the sketch for the circle disappears. See how it disappeared? We're going to go ahead and bring that back. So whenever you have a feature you want to bring it back on the family tree, you click show. This should bring that feature back. And there it is. So we have our helical spiral, and right now it's just a line. It's not a solid body. So we want to make it a solid body. So we're going to do sweep. In this case, the profile, the cross-sectional profile we want to sweep is in a circle. Or if you want to make a special profile, like a triangle shaped profile or square, you can do that. We're going to keep it simple. This is the thickness of the profile. So our wire strands will be 0.01 millimeter thick. And we selected our helical spiral. And there's our solid body. So now we have on our family tree a one solid body, and that's the sweep that we just did. So what's next? We're going to add a plane. And the reason we want to add a plane is because right now this helical spiral is attributed to this circle. So we can't make another helix spiral because it's already based off this circle that we did on sketch 1. We're going to add a different plane so we can add that extra circle. So we'll go here to plane, to search plane. Now I want us to select reference geometry because SolidWorks is parametric modeling, so I need to have a parameter by which to model all the parts. This is going to be our first parameter, this sketch we did. There you go. We're going to select our main planes. We're going to make it 10 millimeters away from the main plane. So this is the front plane. We're going to make a different plane, just 10 millimeters away from it. So we're putting a distance parameter. And now we're going to draw the exact same circle on the plane. So there's two ways to go about this. You can go here to sketch and you can sketch a circle. Or if you want this exact same shape, since you might be doing more complex geometry, I'll show you a feature that can give you that step. So we click sketch, we select our plane, and we do convert entities. So convert entities is going to get this circle and convert it onto this plane. It's going to project onto the plane that we just had. Sounds good. Now we have our plane. We're going to hide the plane. We're going to hide the circle for sketch 1. And we're going to keep our circle for sketch 6. So now we do a helix. There's a helix. Our height is 10. Our pitch is 5. We're going to go in the opposite direction. And there we have our helix. Let's hide this solid body. And let's also hide this first helix / spiral. So we can have our second helix and work on that. So we're going to repeat the sweep function. Sweep. It's going to give us that profile we want. Now, so we have two solid bodies, and then we'll bring them both back. We'll hide this sweep. There's our solid bodies. So what's next? We have our axis, and then we have our strands. We're going to revolve and rotate these strands. And it's going to be a rinse and repeat from there. So which one do you want to move? I want to move this one. Sweep number 1. I want to rotate it around this axis. And here, just do some basic maths. I'm going to grab my calculator. So it says in the PowerPoint slides that it's 48 strands. So 360 divided by 48, 7.5 degrees. And since we're doing strands on both ends, we want 24 of each rotation, of each orientation. So it's going to be 7.5 times 2. We'll add 15 degrees. And you can see there, the original one, this one being the original, and then 15 degrees after you have the second strand. All right. So I'm going to repeat this until you reach the full length of the circle, 360. Bodies to move. And now we'll select both of these bodies. You can select them on the graphical design window, like here in this window space, or you can go here to the left and select them here under solid bodies. So we have sweep 1 and body move / copy 1. Press Control on your keyboard and you select both of them. Rotate. Run your axis. And this time I'm going to rotate it 30 degrees. Before and after. And now, just rinse and repeat. Rotate around our axis. And rotate 6 degrees. I'm getting there. And you can see with each feature we add, it shows up on our family tree. So do I hear 60? There's your 60. 120. There we go. 120. And then one more. $240. The price is right. There you go. So we have a uniform strand, in this case going in one orientation. So we'll go ahead and now worry about the other half. Let's go ahead and hide all of this and bring this one, or sweep 2, and hide the rest. So they're hidden. And now we have the sweep number 2, which is in the opposite orientation from sweep number 1. Now you can see our strand is right there. For sweep 2, all the way at the bottom. Rinse and repeat. And now we have the other orientation. So what do you do next? We're going to bring all of it back together. Here's your lattice. It's annoying. And there's your braid design. So this is an embolization device, 5 millimeters in diameter, 10 millimeters in length. So when we referenced that other table, we saw that there are different varieties. So is there a way that you can make different configurations in SolidWorks for those different varieties? And the answer is yes. Just go here to configurations. And configurations is going to allow you, there's two ways to do it. You can either make manual configurations where you can adjust dimensions of different versions of the same object, or you can make an Excel table and make Excel table configurations. And so we call those design tables. But it's just better if I show you. So here's our part, and it's called part 1 right now. We can make configurations of this part since we know not everyone has requirements of a stent or an embolization device that is specifically 5 millimeters in diameter and 10 millimeters long. Some people might have cases where they need a longer stent or a smaller diameter. So we're going to go to configurations and we're going to add a configuration. This configuration name was 5 millimeters, 10 length. 5 millimeters, 10 millimeters. Description: 5 millimeters diameter, 10 millimeter length. Right? And that's good. Let's do a quick save. We're going to save this as part 1, Republic stent. So we save this part, and we have our first configuration, which is 5 millimeters, 10 millimeters. But this configuration is also the same thing as the default configuration. Nothing has changed. So let's add a new configuration that we can change some stuff to it. Configuration name, 2.5 millimeters, 10 millimeter. So this is going to be 2.5 millimeters in diameter, 10 millimeter length. Now you'll notice at the top left, you have 3 different buttons. You have the default, the 5, 10, and the 2.5, 10. So we're going to switch for 2.5, 10, where we are now. We're going to go back to our family tree. And then we're going to edit our sketch for the circle, which is here. 2.5. It's going to affect everything because we changed the diameter. And we're going to go ahead and do that for the second one as well. .5 radius of 2.5 diameter. Very good there. And to prove to you that this is actually the case, we're going to measure. I'm going to measure this. Awesome. Maximum distance. So the area and perimeter, it gives the value 1. So go ahead, measure the circle. Show it. Show the circle. This ends. There's a circle. We're going to measure that. Diameter 2.5. So we did that under configurations. We basically made 3 separate objects, and within each one we can make configurations or modifications of the same base object. Let's go ahead and add this sketch. So there you go. You have a 2.5 and you have a 5, which is this one. All right. So let's say now you want to render it. You go ahead and render it to make it look presentable. Save this. Let's render it. You want to open the render tools available here on the right or under here in the tab. So right now we have our default appearance and our default background. Let's go edit this scene so we can make it look nice. That looks nice. And we'll edit the appearance to make it look white. All right. And now we just click on the render. So it should be an image with orange blocks. And so that those orange blocks are rendering the image, the finalized output, one by one. And so now you just sit back and wait for the image to finish processing. Nice. And so just so you're clear, just because you change the appearance does not mean you change the material. So on the slides I mentioned it was 75% cobalt chromium, 25% nickel titanium, something like that. We changed the appearance. We didn't change the base material. So most likely under all of that is still stainless steel. So if you're doing simulations, make sure you change it to the proper material properties when you do your simulations. Other limitations. In reality, when you go to manufacture this, you manufacture it by braiding these stems. And so right now they're not braided. It's just a single wire mesh. So just because you can model something does not mean it's easy to manufacture. That's just the first hurdle. Cool. So we're done. And now once we are done, we have our finalized output image. So this is your scene design. This is what you give to the sponsor. But to save the image, you want to go here and click Save Image. And this image will just basically save it as an image, PNG or JPG, I think in this case. And you give it a nice name. Extend render. And always itemize your versions. So if this is your first version of render, I use version 1. So now that image is saved. We're going back now to our SolidWorks screen. And this would be the end of the modeling session.